We're going to do one more type of formulas. They're called sum and difference formulas. You do not need to memorize these. You can just have them written out in front of you. But I do want to teach you how to use them. So my first one is if I have a cosine of two things that are being added together, I can rewrite that as cosine of the first thing times cosine of the second thing minus sine of the first thing times sine of the second thing. So the second one is if we have the same thing but they're being subtracted. I'm going to show you the intermediate step. You don't actually need to write it down, but I want you to know where it comes from. So what I can do is I can take that first identity and I can rewrite, I can use that first identity, substitute in negative beta, that's that letter, that's the Greek letter beta, it looks like a B, for my second term. And then I do the same thing with sine. I substitute in negative beta for my second term. So basically what I did was I took the first identity and I just said that instead of putting in beta, I'm going to put in negative beta. So I did that in there. So this second one is going to be equal to cosine of alpha times cosine of beta. Remember, if you have a cosine of a negative value, it's exactly the same as the cosine of the positive value. The only thing that's going to change with this second equation is that if I take the sine of a negative thing, then that's actually the same as negative sine of that value. So this second thing is going to change signs. If you did not understand anything I just did, you can just write down this identity right here, and then the one above that's circled. Those two you will have to have written down. This thing here is you don't need to write it, so I'll just write that. Don't need to put in your notes because we're only going to be using the circled ones. So my next two identities are similar. You might be able to guess. The only difference is that they're going to have to do with sine. So if we have sine of alpha plus beta, again, Greek letter A and B, that's going to be the same as sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So this is my my first sine identity. Now I'm going to do the same thing that I did previously. I'm going to find sine of alpha minus beta by taking my equation and substituting in my negative beta. So when I do that, we'll see what happens in just a second. So again, remember that if I have, write this out, if I have cosine of negative, it actually doesn't change the sign of anything, so it just ends up being this. If I have sine of a negative, that does change the sign, so the second one ends up being minus. Now again, if you didn't quite understand what I just did, that's fine. You can just write that identity down. So right now, the four that you need are the four that I drew a box or a circle around. If you wrote down those two intermediate steps, that's fine. That's kind of me deriving, showing you how I got those next two, but you do not need to have those memorized. In fact, you don't need to have any of these memorized. I just need you to write them down and be able to use them. So let's go and do a few examples of using them right now. So we're going to simplify these two things, and you might actually recognize these. These are the cofunction identities that we saw probably many weeks ago. So we're going to solve these, however, using the identities that we have. So I'm going to write out this cosine of pi over 2 minus theta. Remember, I have that one cosine of alpha minus beta is equal to cosine alpha, cosine beta, plus sine alpha, sine beta. And in this case, my alpha value is pi over 2. My beta is going to be that theta. There's lots of Greek letters in this. You can see with trigonometry, we do tend to use a lot of Greek letters. So we can write it out using that identity above. I get cosine of pi over 2 times cosine of theta. It's not negative here. Keep in mind in the identity, this is positive. Plus sine of pi over 2 times sine of theta. So at this point, I'm hoping that you're able to maybe do these problems without necessarily just looking at your unit circle, but if you don't remember what to do, I'll give you a little hint. So it's always a good idea to draw a picture. We know that pi over 2 is right here. This is pi over 2. This is the value 0, 1. So at pi over 2, cosine of pi over 2, we can see is the x value, which is 0. I don't have a value for theta, so I'm going to just write it as cosine theta. Sine of pi over 2, that's my y value, so that's going to be 1. So actually, if I just simplify this out, I am going to just get sine of theta. That is an identity that I think we've seen before, but I just think I now think it's good that I can show you where it comes from. I want you guys to pause the video, try on your own to do the exact same thing with number 2. So for this one, remember we have the formula sine of alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. So in this one, my alpha and beta are actually the same thing as previously. So I'm going to get sine of pi over 2 times cosine of theta minus cosine of pi over 2 times sine theta. Then again, using your unit circle, we can see that sine of pi over 2 is 1. Cosine theta we can't simplify. Cosine of pi over 2 we can see is 0. So if we simplify this out, we do end up getting cosine of theta. So the third example, you actually have two parts of this that are things that we've done in the past, and one part that's going to be new. So I think that the first two parts look confusing because they're using alpha and beta and not theta, but it's actually similar things to what you've done in the past. So go ahead, pause the video, try those two out, try A and B, and then we'll do C together. So the first thing that we did for this problem was we find cosine of alpha. They tell us that alpha is in the second quadrant. It's between pi over 2 and pi. The reason that that's going to be important is because that tells us that cosine is going to be negative. That's a useful thing to know there. So now I'm going to draw a triangle there, and this angle right here is my alpha. Remember, we're using the angle alpha, not theta. Sine is 4 over 5, which means my opposite side of 4 is 4. My hypotenuse is 5. That's going to mean that my adjacent is 3, or you can think of it as negative 3. By the way, this isn't drawn to scale. So my adjacent is negative 3. My cosine is negative 3/5. You're going to do a similar thing for letter B. I'm going to draw another one right here. So we know that that one is in quadrant 3. It's between pi and 3 pi over 2. Cosine is still negative in that area. However, sine is also negative. So I ended up getting sine is negative 2 radical 5 over 5. That looks really confusing, but you can just use the same ideas as what you were using before. My opposite side is negative 2 radical 5. My hypotenuse is 5. You can use the Pythagorean theorem to figure out this x value. So I'm going to get x squared plus negative 2 radical 5 squared is equal to 5 squared. That gives me x squared plus 20 is equal to 25. If I solve that out, I get x equals radical 5. And actually, generally when you're solving these, usually when we have like x squared equals 5 is what we would get. In most math problems, you would actually take the square root and then you would find plus or minus. And most of the time when we're doing these with trigonometry, we keep the positive. However, in this case, because we know that we are in that third quadrant, our x value, which is our cosine, needs to be negative. So it's going to be a negative radical 5. So my answer for this one is going to be negative 5 over 5. So that stuff's review, but you might have forgotten it or you might have been confused about it in this context. For part C, that one is not review. That one is the new stuff that we have in this chapter. The nice thing about this one is we do have a formula that lets us solve this out. So we know the formula is sine of alpha cosine beta plus cosine alpha sine beta. And actually, we have all 4 of those things here. So sine of alpha, we know right here is 4/5. Cosine of beta, we just found in part B, that's negative radical 5 over 5. Cosine of alpha, we found in part A, that's negative 3/5. And sine of beta is negative 2 radical 5 over 5. So now you're just going to use a little bit of algebra to solve this out. We get negative 4 radical 5 over 25 plus 6 radical 5 over 25. Those two things can actually be combined. We have the same denominator. Negative 4 radical 5 plus positive 6 radical 5 gives us 2 radical 5.